The James Webb Space Telescope captured an image of a faraway star surrounded by crisp, circular ripples earlier this year. The image was quickly dubbed bonkers by scientists, who speculated that it may represent an alien-created superstructure spanning many light years across. Even astronomers were perplexed by the bizarre concentric geometric circles. Is the newest JWST finding, which resembles a cosmic thumbprint, a genuine extraterrestrial megastructure? Will this be the ultimate proof that we are not alone in the universe? Join us as we investigate what the JWST captured that stunned everyone. Judy Schmidt, a citizen scientist, posted the photograph on Twitter in July, triggering a flood of responses and puzzlement. It depicts WR140, a star surrounded by regular ripple-like rings that progressively fade away. The circles, on the other hand, are not exactly round, but rather have a square-like appearance, generating suspicion about possible alien origins. I think it's just nature doing something that is simple, but when we look at it from only one viewpoint, it seems impossible at first to understand that it is a natural phenomenon, Schmidt said in an interview. Why is it formed this way? Why is it so consistent? Two Australian astronomers explain in two papers published recently in Nature and Nature Astronomy that the 17 concentric rings seen encircling the star are actually a series of mammoth dust shells formed by the cyclic interaction of a pair of hot stars, one of which is a dying Wolf Riot locked together in a tight orbit. Before we get into details of this remarkable finding, you may be wondering what a Wolf Riot star is. Wolf Riot stars are massive stars that are at an advanced stage of stellar development and are shedding mass at a rapid rate. They have limited lifespan and are hence relatively rare objects, with masses generally larger than 25 times that of the Sun. We know about roughly 220 in our own galaxy, but scientists believe the Milky Way may contain 1,000 to 2,000 such objects, the most of which are obscured by dust. Given that the typical temperature of a Wolf Riot star is higher than 25,000 Kelvin, and that they can have luminosities up to 1,000,000 times that of the Sun, the tremendous winds created by these objects are assumed to be caused by intense radiation pressure. These winds expel around 10 solar masses of material each million years at speeds of up to 3,000 kilometers a second, resulting in the distinctive wide emission lines in these stars' spectra. Normal stars have narrow emission lines. Wolf Riot stars are thought to be born from O stars that have lost their hydrogen envelopes, revealing an exposed helium core. They are divided into two categories. WN stars' spectra are dominated by helium and nitrogen emission lines with some carbon, whereas WC stars have no nitrogen and are dominated by helium, carbon and oxygen emission lines. It is thought that around half of all Wolf Riot stars exist in binary systems. Another Wolf Riot star or a compact companion, such as a black hole or neutron star, have been proposed as possible companions. There is some evidence supporting each of these scenarios, but definitive observations have yet to be produced. So far, the only verified companions of Wolf Riot stars are other massive stars. It is believed that Wolf Riot stars have a spectacular end as either a Type 1b or Type 1c supernova explosion at the conclusion of their existence. So what are the secrets of WR140? The star WR140 is classified as a Wolf Riot star. The stars in this group are some of the most extreme in the universe. In a spectacular but infrequent event, they can release a cloud of dust into space that is several times larger than our solar system. Due to the powerful radiation field around Wolf Riots, dust and wind are blown out from the star at speeds of thousands of kilometers per second, or roughly 1% the speed of light. Though every star generates a stellar wind, these high achievers create something more akin to a celestial hurricane. This wind carries dust-forming particles like carbon that are streaming out into space. WR140 is a binary system that contains one of the few dusty Wolf Riot stars known to exist. Its companion star is a gigantic blue supergiant with a fierce wind of its own, and they're orbiting each other. Even though scientists have only discovered a small number of systems like WR140 across the whole Milky Way, these few have given them the most spectacular and unexpected surprises. In contrast to what one might assume, Dust doesn't simply stream out from the star to form a hazy ball, but rather in a cone-shaped region where the winds of the two stars collide. Since the binary star is always moving around its orbit, the shock front must do the same. The sooty plume naturally wraps into a spiral similar to the jet from a revolving lawn sprinkler. The WR140, on the other hand, has a few more tricks up its sleeve for adding more rich complexity to its spectacular display. The orbits of the two stars are not circular but elliptical, and furthermore, dust production turns on and off episodically as the binary nears and departs the point of closest approach. Fortunately, the team at the University of Sydney had previously been researching this star for more than 20 years, so they were well positioned to apply physics to understand what they were seeing. Their model, which was published in Nature, explains how the star forms the spectacular pattern of rings visible in the Webb photograph. By modelling all these effects into the three-dimensional geometry of the dust plume, the team tracked the location of dust features in three-dimensional space. The Australians employed interferometry, a type of imaging technique to retrieve sufficiently fine images of WR140 for the research. This technology acted like a zoom lens, magnifying the light from the 10-metre mirror of the Keck telescope in Hawaii, one of the world's largest optical telescopes. They observed that their model of the expanding flow matched the data perfectly by meticulously tagging images of the flow acquired at the Keck Observatory. Except for one little annoyance. The dust was not where it should have been, so close to the star. Chasing that minor misfit led them to a phenomenon never caught on camera. In the absence of external forces, each dust spiral should expand at a constant speed, said Yunuo Han, co-author of the paper. We were puzzled at first because we could not get our model to fit the observations until we finally realized that we were seeing something new. The data did not fit because the expansion speed wasn't constant, but rather that it was accelerating. We'd caught that for the first time on camera. We know that light has momentum, which implies it may push on matter, a phenomenon known as radiation pressure. The result of this process, in the form of matter speeding across the universe, is seen everywhere. However, catching them in the act has been a fairly tough procedure. Because the force decreases rapidly with distance, it is necessary to observe the movement of matter in a strong radiation field extremely accurately to detect material being accelerated. This acceleration proved to be the one lacking component in the WR140 models. Their numbers did not match because the expansion speed was not constant. The dust was being accelerated by radiation pressure. It was unusual to capture that for the first time on camera. Each circle is as though the star unfurls a massive dust sail. In one sense, we always knew this must be the reason for the outflow, but I never dreamed we'd be able to see the physics at work like this, said Professor Peter Tuthell from the Sydney Institute for Astronomy at the University of Sydney, a co-author in both papers. When I look at the data now, I see WR140's plume unfurling like a giant sail made of dust. When it catches the photon wind streaming from the star, like a yacht catching a gust, it makes a sudden leap forward. The end result of all this physics is breathtakingly beautiful. Every 8 years, WR140 blasts out finely crafted smoke rings like a clockwork toy. Each ring is etched with all of this fantastic physics written in minute detail. All scientists have to do is wait until the growing wind inflates the dust shell like a balloon until it is large enough to be imaged by their telescopes. The binary then returns to its orbit 8 years later, and another shell develops similar to the one before it, developing inside the bubble of its predecessor. Shells continue to pile up like a phantom set of huge nesting dolls. 8 years later, as the binary returns in its orbit, another ring appears, the same as the one before, streaming out into space inside the bubble of the previous one, like a set of giant nested Russian dolls, said Professor Peter Tuthell. However, it wasn't until the new Webb image arrived in June that they realized how well they had landed on the appropriate geometry to understand this remarkable star system. Prior to that, they had no idea how well their theory would hold up. There were not one or two, but more than 17 finely crafted shells, each one nested within the one before it. That implies the oldest, outermost shell shown in the Webb image had to be thrown around 150 years before the newest shell, which is still in its infancy and racing away from the bright pair of stars at the system's centre. The Wolf Riots have given one of the most exciting and beautifully structured images published by the new Webb telescope with their stunning plumes and furious fireworks. This was one of Webb's early photographs, and astronomers are anxiously waiting to see what new miracles this telescope will transmit down to them. Let's hear your thoughts in the comments section down below. Subscribe to our channel if you enjoyed the video.